The National Electrical Code does not specifically prohibit the installation of radiant floor heating cables under concrete shower stalls. However, Section 422.50 of the National Electrical Code requires that electrical components and wiring in wet locations, such as showers, must be approved for such use. Many manufacturers of radiant floor heating cables specify that their products can be installed under concrete shower stalls, provided certain conditions are met. These conditions typically include, firstly, using a specifically designed cable rated for wet areas; secondly, installing the cable according to the manufacturer's instructions; thirdly, protecting the cable from damage during installation; and fourthly, covering the cable with a minimum of 2 inches or 5 centimeters of concrete or mortar. Even though the cable may be rated for use under showers, it is important to note that concrete is not waterproof. Installing a waterproofing membrane over the concrete, such as a sheet of polyethylene or a liquid-applied membrane, is highly recommended. The waterproofing membrane can help prevent moisture from penetrating the concrete and reaching the radiant floor heating cable. Based on the National Electrical Code regulations and manufacturer instructions, it is generally permissible to install radiant floor heating cables onto concrete shower stalls. However, it is essential to follow the manufacturer's instructions carefully and to use a waterproofing membrane to protect the cable from moisture. When installing radiant floor heating cables under concrete shower stalls, several crucial factors must be considered to ensure safety, code compliance, and long-term performance. Firstly, selecting the right cable is paramount. The cable must be specifically designed and rated for wet environments. This rating ensures that the cable's installation and construction can withstand constant exposure to moisture without degrading or posing an electrical hazard. Verify that the cable is listed and labeled for wet location use by a recognized testing laboratory. Secondly, adherence to the manufacturer's instructions is non-negotiable. These instructions outline the precise installation methods, spacing requirements, and embedding depths necessary for the cable to operate safely and efficiently. Deviating from these instructions can lead to overheating, cable failure, or even electrical shock. Pay close attention to the recommended spacing between cable runs to ensure uniform heat distribution across the shower floor. Thirdly, protecting the cable during installation is critical. The concrete pouring process can be surprisingly harsh, and the weight of the concrete and the tools used to spread it can easily damage the heating cable. Before pouring the concrete, carefully inspect the cable for any signs of damage, such as cuts, abrasions, or kinks. Use non-metallic straps or clips to secure the cable to the subfloor and prevent it from shifting during the pour. After the concrete has been poured, avoid walking directly on the cable until it is fully cured. Fourthly, ensuring adequate concrete coverage is essential for both protection and heat distribution. The manufacturer's instructions typically specify a minimum concrete thickness of 2 inches or 5 centimeters over the cable. This concrete layer serves to protect the cable from physical damage and helps to distribute the heat evenly across the shower floor. Use a leveling compound to ensure that the concrete surface is smooth and even. Fifthly, waterproofing is a crucial step in preventing moisture from reaching the heating cable. Concrete is porous and will absorb moisture over time, which can eventually lead to corrosion of the cable and electrical failure. Installing a waterproofing membrane over the concrete creates a barrier that prevents moisture from penetrating the concrete and reaching the cable. Choose a waterproofing membrane that is specifically designed for use in wet environments, such as a sheet of polyethylene or a liquid-applied membrane. Follow the manufacturer's instructions for applying the waterproofing membrane carefully. Sixthly, electrical connections must be made in accordance with the National Electrical Code and local electrical codes. All electrical connections must be made in a junction box that is accessible and protected from moisture. Use wire connectors that are specifically designed for use in wet locations. Ground the heating cable in accordance with the National Electrical Code requirements. Seventhly, testing the cable before and after installation is essential to ensure that it is functioning properly. Use a multimeter to test the cable's resistance before and after installation. The resistance should be within the manufacturer's specified range. After the concrete is cured and the waterproofing membrane has been applied, test the heating cable by turning it on and checking for even heat distribution across the shower floor. 8th, documentation is often overlooked but is crucial for future maintenance and warranty claims. Keep a record of all installation details, including the cable type, manufacturer's instructions, wiring diagrams, and inspection reports. This documentation will be invaluable if you ever need to troubleshoot a problem or file a warranty claim. Remember that local codes and regulations may vary, so it's essential to consult with a qualified electrician or building inspector to ensure that your installation meets all applicable requirements. Neglecting these considerations can lead to safety hazards, code violations, and costly repairs. Always prioritize safety and follow best practices when installing radiant floor heating cables under concrete shower stalls. Let's delve deeper into some specific aspects of installing radiant heat cables under concrete shower stalls. Firstly, understanding the National Electrical Code requirements is crucial. Section 422.50, as mentioned earlier, is a key reference point. This section emphasizes the need for electrical components in wet locations to be approved for such use. Approval generally means that the component has been tested and listed by a recognized testing laboratory such as Underwriters Laboratories or Intertek to meet specific safety standards for wet environments. Look for the UL or ETL listing mark on the radiant heat cable and any associated components. The National Electrical Code also addresses grounding requirements for electrical equipment in wet locations. Proper grounding is essential to prevent electrical shock hazards. Ensure that the heating cable is properly grounded in accordance with the National Electrical Code requirement. Secondly, selecting the right type of radiant heat cable is vital. There are two main types of radiant heat cables commonly used in floor heating applications: resistance cables and self-regulating cables. Resistance cables provide a constant amount of heat output regardless of the surrounding temperature. Self-regulating cables adjust their heat output based on the surrounding temperature, providing more heat in colder areas and less heat in warmer areas. For shower applications, resistance cables are generally the preferred choice due to their consistent heat output and lower cost. However, self-regulating cables may be suitable in certain situations where temperature variations are a concern. Thirdly, proper cable spacing is essential for uniform heat distribution. The manufacturer's instructions will specify the recommended spacing between cable runs. This spacing is typically expressed in inches or centimeters. The closer the cable runs are to each other, the more uniform the heat distribution will be. However, spacing the cables too closely can lead to overheating and cable failure. Conversely, spacing the cables too far apart can result in cold spots on the shower floor. Follow the manufacturer's instructions carefully to ensure proper cable spacing. Fourthly, the type of concrete or mortar used to embed the heating cable is important. Use a concrete or mortar mix that is specifically designed for use with radiant floor heating systems. These mixes typically contain additives that improve heat transfer and prevent cracking. Avoid using concrete or mortar mixes that contain excessive amounts of moisture, as this can lead to corrosion of the heating cable. Fifthly, the waterproofing membrane plays a critical role in protecting the heating cable from moisture. There are several types of waterproofing membranes available, including sheet membranes, liquid applied membranes, and trowel applied membranes. Sheet membranes are typically made of polyethylene or rubber and are applied in overlapping sheets. Liquid applied membranes are applied with a brush or roller and form a seamless, waterproof barrier. Trowel applied membranes are applied with a trowel and are typically used to create a sloped shower floor. Choose a waterproofing membrane that is compatible with the type of concrete or mortar used and that is specifically designed for use in wet environments. Sixthly, consider the use of a thermal break. A thermal break is a layer of insulation that is installed between the concrete slab and the subfloor. The thermal break helps to prevent heat lost through the subfloor and improves the energy efficiency of the radiant floor heating system. Thermal breaks are particularly important in showers that are located on exterior walls or over unheated spaces. Seventhly, consider the use of an anti-fracture membrane. An anti-fracture membrane is a layer of material that is installed between the concrete slab and the tile or stone flooring. The anti-fracture membrane helps to prevent cracks in the concrete slab from telegraphing through to the tile or stone flooring. Anti-fracture membranes are particularly important in showers that are subject to heavy use or that are located in areas with seismic activity. Eighthly, document every step of the installation process, including photos and videos. This documentation will be invaluable if you ever need to troubleshoot a problem or file a warranty claim. Keep a record of the cable type, manufacturer's instructions, wiring diagrams, inspection reports, and test results. Store this documentation in a safe place where it can be easily accessed. Let's elaborate further on some additional considerations when installing radiant heat cables under concrete shower stalls. Firstly, consider the subfloor material. The subfloor is the layer of material that the concrete slab is poured onto. The subfloor material should be strong, stable, and capable of supporting the weight of the concrete slab, the heating cable, and the tile or stone flooring. Common subfloor materials include plywood, oriented strand board, or concrete backer board. Ensure that the subfloor is properly prepared before pouring the concrete slab. Secondly, consider the slope of the shower floor. The shower floor should be sloped towards the drain to allow water to drain properly. The slope should be gradual and consistent to prevent water from pooling on the shower floor. The National Electrical Code typically requires a minimum slope of 1/4 inch per foot. Thirdly, consider the type of drain used in the shower. The drain should be compatible with the radiant floor heating system. Some drains are designed to be installed directly in the concrete slab, while others are designed to be installed on top of the concrete slab. Choose a drain that is easy to clean and maintain. Fourthly, consider the type of tile or stone flooring used in the shower. The tile or stone flooring should be durable, slip-resistant, and waterproof. Common tile and stone flooring materials include ceramic tile, porcelain tile, and natural stone. Ensure that the tile or stone flooring is properly installed to prevent water from penetrating the concrete slab. Fifthly, consider the use of a programmable thermostat. A programmable thermostat allows you to set different temperature schedules for different times of the day. This can help to save energy and reduce your heating costs. Programmable thermostats are available in a variety of styles and features. Choose a thermostat that is easy to use and that meets your specific needs. Sixthly, consider the use of a ground fault circuit interrupter, or GFCI. A ground fault circuit interrupter is a safety device that is designed to protect people from electrical shock. The National Electrical Code requires that all electrical circuits in wet locations, such as showers, be protected by a ground fault circuit interrupter. Ensure that the heating cable is connected to a ground fault circuit interrupter protected circuit. Seventhly, consider the potential for electromagnetic fields. Radiant floor heating systems emit electromagnetic fields, or IMFs. Some people are concerned about the potential health effects of exposure to electromagnetic fields. If you are concerned about electromagnetic fields, you can take steps to minimize your exposure, such as using shielded heating cables or installing a grounding system. Eighthly, consider the long-term maintenance requirements of the radiant floor heating system. Radiant floor heating systems are generally low maintenance, but they do require some periodic maintenance to ensure optimal performance. This maintenance may include checking the thermostat settings, inspecting the heating cables for damage, and cleaning the drain. Following these additional considerations will help you to ensure that your radiant floor heating system is installed safely, correctly, and efficiently. Remember that consulting with a qualified electrician or building inspector is always recommended to ensure compliance with all applicable codes and regulations.